And now, please welcome to the stage, Sha-Chelle Manning.
Welcome. For over 60 years, DARPA has had the mission of preventing and imposing technological surprise. As the Chief of Commercial Strategy, my team and I are keenly focused on bridging that gap between tech development and the deployment of that technology into markets, both commercial and military. This panel is focused on one aspect of that, novel systems of systems, and the intersection of our military and commercial capabilities for enhanced national and economic security. As the Honorable Shu spoke about, we want to delve into how an agile private sector can more effectively infuse complex, powerful technologies into a sometimes cumbersome government. I'm excited about this topic because while serving as an executive at a U.S. public independent oil and gas company prior to DARPA, we had the daunting task of developing and scaling advanced technologies for shale oil and gas exploration. To compete in that global market at that time, we would roughly have had to drill 17 wells each, a mile down and a mile out for every one well drilled in another part of the world. Or could we find and scale advanced technology that would enable us to be more efficient, competitive, and precisely drill, staying in that sweet spot, so we could increase production and decrease the number of wells, also being a better steward of the environment? I turned to several DARPA performers that were developing navigation technologies for GPS-denied environments. You should have seen their jaw dropped when I had to explain that their DARPA-inspired MEMS, PNT, and some of the electronics would have to survive massive shock and vibe in high temperature for days. By the way, you'd have to need enough devices manufactured to do this over 300 times for over 3 million feet every year. The results speak for themselves, and the U.S. independents were able to become an energy powerhouse and disrupt the global market. Without further ado, let's bring out our amazing panelists. Chris Brose is the Chief Strategy Officer of Anduril Industries, a venture-backed company transforming defense with advanced technology to bring in a new age of autonomous operations. Prior to this, he led the staff of the Senate Armed Service Committee in overseeing the budget and programs throughout the Department of Defense and the Department of Energy. He also is the author of The Kill Chain, Defending America in the Future of High-Tech Warfare, published in 2020. A great read, I might add. Thank you. Rusty Thomas now heads up Amazon's new Kuiper constellation of broadband internet satellites for the government and military connectivity. This follows decades of leadership in the spacecraft and satellite constellation business at DARPA, SpaceX, Motorola, and others. The power to be unleashed by the new satellite constellations will transform our world, and Rusty is at the pulse. Victor Peng. Victor is now president of AMD's Adaptive and Embedded Computing Group, which was formed upon AMD's acquisition of his previous company, Xilinx, where he was CEO. He is leading and providing the most comprehensive portfolio of adaptive computing platforms capable of powering a new age of adaptability and artificial intelligence. Okay, to start with, I'd like each of you to take 2 minutes or so to share the tech battle scar and story you are most proud of. Chris.
The story that I'd say I'm most proud of, in the early days of Anduril, we were a small company when I joined out of government. We were 40 people. We had to generate some momentum to, actually become the larger company that we aspired to be. And at that point, it was kind of, all hands on deck on the initial program that we were working, which was a small prototype with, of all places, Customs and Border Protection. Coming out of government, I did not expect the first thing that I would be doing would be, kind of corralling robots on the southern border. But it was something that, everybody chipped in on, from the CEO on down. And, it was able to generate, kind of real leverage and lift into the future work that we were able to do.
Thank you. And Rusty.
Yeah, sure. I think the story that I'd like to relate goes way back machine, back in the mid-90s when I was at Motorola doing Iridium Mark I. it's always tough when you're developing advanced technology to make sure you put in a culture of innovation and that the best idea wins or the best analysis wins. How do you get that best idea to the forefront no matter who it is in the room? And what happened to me in the mid-90s, we were developing the first generation Iridium satellites to do something that had never been done before. That's launch them on a range of launch vehicles. Before that, you pretty much designed a satellite for a rocket. So we were designing it to launch the bulk on the Delta II rockets, but we were also designing them to launch 7 at a time on Proton and 2 at a time on Long March. So a diverse set of rockets, 3 different countries to work with, and I was a 25-year-old, 26-year-old junior engineer on the launch integration team doing the couple loads work. And at the time, I had a wonderful workstation that I think Victor knew a little bit about because he was there. Silicon Graphics was able to build super, very powerful computers that really didn't exist anywhere else if you're trying to use PCs to do finite element analysis or advanced analysis. So to get to my point, I go to China for one of the ICD meetings, and I sit down with my 100,000 degree of freedom results from the coupled loads and the stiffness analysis between the Chinese rocket and ours. I couldn't show them the details of the analysis. I could just show them the overview because of ITAR restrictions. But at the other side of the table were all the Chinese scientists, and in their culture and in many cultures, you don't show up the senior folks in the room, at least in the very public sense that I was about to, because their analysis was wrong. And I had to change it, otherwise we were going to have a launch failure. So I worked through that back and forth with them, back and forth. They finally realized I was right. They finally realized of the 50 people in the room, my detailed finite element analysis, thanks to the great tool I had and the best analysis, was correct, and they were going to change it. But there was a heated exchange behind with the in a foreign language that I could not understand. I had been learning a little Russian. My counterpart had been learning a little bit of Chinese as we tried to figure out how to do the interactions. And finally, they stopped. They came back, said we accept. And I said, I turned to my friend and said, well, that was a lot of talk for that. He said, yeah, I think most of the discussion was actually about your mother. They did not like that. So the trick is, and you work at the best commercial companies out there that I've had a lot of experience with, and they really do put that innovation concept of what's the best idea, how does that win, and it doesn't matter how senior you are, how junior you are. I'm at Amazon now. They have wonderful mechanisms and leadership principles that bring out the best. So I think that's the scar that actually helped me move to where I'm going today. Thanks.
Thank you.
Yeah, so when I first started at Xilinx leading engineering, we started engaging with TSMC for the first time. So it was a new foundry. This is back in the 28 nanometer generation. So they're introducing high-K metal gates for the first time, which seems so passé these days, right? But it was leading edge technology. And as though, a new foundry, new technology wasn't enough, we were doing multiple different programs at the same time. And, one of them was, very proud to say what we called stacked silicon interconnect technology, which was integrating multiple active die on a silicon interposer. And we started sampling this back in 2011, so more than a decade ago, we were doing what today people refer to as chiplets. So it was great, we had this really great technology, but then as we are going from sampling to trying to ramp up production, we had a little problem that we didn't have great yields. So for several weeks, every week, we had meetings with the CEO to see how we were going to drive the yields up. But fortunately, we did deliver for our customers. And indeed, eventually, we exceeded our yield targets. And now our 7 nanometer Versal product is the 4th generation of doing integration with multiple die, including multiple die with HBM stacks. So it was a hard beginning, but a good ending, and really happy that AMD is actually recognized as one of the leaders in these integration technologies in advanced packaging. So,
thank you, Victor. Chris, I want to ask you, in your book, The Kill Chain, you point out that sometimes commercially available technology surpasses some used by our military. What is an example from your experience where the military was able to reach out and adopt cutting-edge technology, and what enabled that to happen?
Yeah, that's a great question. So I guess, I'd kind of wind the clock back to about 3.5 years ago, and this was the start of the work that Anduril began doing on counter-drone technologies. And I would challenge the premise a little bit because I did not see the military sort of reach out for it. The benefit was actually At the time, there was an event that DITRA and DIU were sort of co-sponsoring, really kind of looking for alternative solutions. So, typically the way this happens in the DoD is we have, 100 people 10 years ago came up with a requirement for what they thought the solution was going to be now. And this was kind of the alternative of that, right? Which was, the premise of the competition was we think that we can find drones, but we need alternative mechanisms to defeat them. So we spun for about 6 or 7 weeks on what we thought was actually where the technology was going to force kind of solutions to go, which was a completely autonomous, essentially kind of hard kill mechanism. A drone that could essentially take a target track, go up, have enough intelligence and enough autonomy, sensors on board to acquire the target and just physically run into it. And the competition was run in a very same way, right? It was, can you find drones? Can you defeat drones? This was not sort of a competition over PowerPoint presentations and white papers. It was like, can you actually do the thing that is required? We didn't do phenomenally well, but we did well enough to kind of attract the interest of Special Operations Command. And, basically they saw in the solution that we had brought, admittedly a very kind of janky prototype, something that they needed downrange. And, I think what was successful and sort of meaningful here was this was not a community that was sort of thinking about the distant future, thinking about sort of where the state of technology was going to be in a decade. It was a community that needed solutions now, and it was not a solution that, people had been thinking about, right? It was not something that they could have predicted. It was sort of a disruptive approach to a problem that was incredibly urgent for this community. So, within a few months of that, we had systems downrange in Iraq and Syria, dealing with the problems as they were. And over the course of the next 3 years, that threat evolved. Our technology had to evolve. Through the experience of actually having to deal with the problem in the real world, the technology got better, the solution got better. We realized, along with the rest of the community, that finding drones is not a solved problem. So we got pulled into that as well. All this is to say, I think the reason it was successful was because the government started with a problem, not what they believed the solution was. Which opened up the sort of creative space for industry to show up with disruptive technologies, in our case, completely derived from commercial technologies, to nonetheless solve an incredibly urgent problem. And that was the second part, right? This was a problem that human beings in the Department of Defense cared deeply about solving on a rapid timeline, and they were willing to take some risk to use technologies that were somewhat low sort of technology readiness level to nonetheless see if they could do something better. So that whole process happened incredibly quickly. It allowed us to sort of move through lots of different versions of that solution, kind of expand on the work that we're doing, and ultimately end up in a pretty large contract with Special Operations Command.
Thank you, Chris. Okay, Rusty. GPS satellites developed for the military, they were a game changer for society at large with many unanticipated applications. Now there are these small, more capable satellite constellations. They're being deployed on an unprecedented scale. Amazon, SpaceX, OneWeb, and others. What game-changing capabilities do you foresee that this will bring to society?
Yeah, I think there's kind of 2 layers, a near-term and a far-term answer to that. And of course, the near-term tagline is commercial, broadband, low-latency, global connectivity for the underserved areas of the world, no matter where you're at. My mother lives in rural Indiana in the same house I grew up in and still does not have cable or fiber or any real broadband other than a basic connectivity with a cell phone tower. So just getting the ability to do basic broadband connectivity to the underserved parts of the world is going to open up a lot of capabilities to society in general. A couple examples. I go to my house where I've turned on my lights into automation sensors that talk to Alexa, and I say, Alexa, turn on the kitchen, or Alexa, good night, and my whole house just turns off. Much better than walking around trying to chase after the kids, right? And so I really think that type of automation, that type of home advances, things you need to do. When you talk to an Echo, you're not actually talking to a supercomputer on your desk. You're talking to an AWS cloud that has wonderful analytics and wonderful analysis capabilities, software on it, that then brings the answer back to you. That's only there if you have broadband, low latency connectivity. So giving that around the world is going to open up that type of automation tool set to anybody who wants to have that immediate connectivity to essentially a supercomputer on a little low-cost puck in your house, right? And then there's the advanced pieces where you're going to see things like telemedicine. Right now, you can provide a sensor that tells you how the patient might be, and things that might be inside that's fairly automated, but you need to have the results of that, which usually are large files, looked at by an expert. And had telemedicine in areas that are remote, just like they don't have broadband, they might not have a nearby expert in that medicine area. So to be able to move from remote areas of Africa or remote areas of Indiana, whatever that is, to get that information to an expert and get it right back in real time to help the person or help the community is going to be a game changer of significance. So I think that's the near term. And then I'll just end it with the longer term. I also see this evolving not just as broadband SATCOM as a service that will be providing that to commercial users, enterprise, military users, but we're also going to start seeing a shift to space as a service in general, not just SATCOM. We're going to see the ability to hook into space-to-space links optically to have broadband connectivity through space, hosted payload options that could potentially really change the game by allowing large numbers of small companies to engage when you don't have to worry about a bus or a launch vehicle or the operations center on the ground. You bring your mission and your payload, and you can bring these layers of the future that will have extra capability that aren't just SATCOM. I think that's going to evolve over the next 5 or 10 years out of the baseline capability that we're seeing with these mega constellations.
Thank you so much.
Thanks.
Along those lines, Victor, we heard earlier with our MTO panel, CHIPS Act recently passed to reinvigorate the U.S. semiconductor industry. We've had similar efforts that have been done such as Semitech. What's an experience that you've had that demonstrates what the government can do with the CHIPS funding to move our nation's industry forward?
Yeah, so a lot of people have talked about what it takes to bring onshore really advanced manufacturing, and that's why the allusion to Semitech. Yeah. I actually want to take a little different track and talk a little bit about the design part of the equation, because that's equally important for the leadership of U.S. has in semiconductors, and a lot of what Rusty and Chris just talked about isn't possible without some design as well, right? Senior manufacturing and design. And I think what we should do is we should really look towards models that work. And here we are in DARPA. And I think, I run the foreign xilinx part of AMD. And we've had a long, great relationship with DARPA. And there's been successful models where it really helped push the state of the art of semiconductors. One such program, I talked about, silicon interposers and chiplet technologies. Another one that we had some support from DARPA on was advanced development. It was actually implemented first as a chiplet, and this is high-performance ADCs and DACs closely integrated with digital. But then we monolithically integrated that on a single die with our RF SoC product. This, again, was done the first time, one of the first at 28 nanometers. So you have a multi-core ARM SoC together with FPGA fabric, security features, high-performance ADCs and DACs, and programmable I/O and SerDes. So, the ultimate software-defined radio, very scalable for antenna array systems, but applications, both in the commercial space and, of course, in the military space. And it's been such a great win-win, right? I mean, it's been really good for security. It's being adopted in many, many different applications. It's a commercial win, which is you need that virtuous cycle to make it a really sustainable thing. You could always do, small instances of one really cool technology, but to make it scale and to make it, and I know scale is one of your favorite things, and make it really sustainable for the government and the industry, you need that success. And so I think not just DARPA, but I think there are successful models, and I would hope that we lean on some of the models that we have. We don't have to create whole new ones. If there's a reason to, you should do that, but I think there's been some good models. So
that's great. Yeah. Okay, so I have a few more questions for our panelists. And I want to remind the audience that we have to submit some of their own. I already gave them all a hard time because I heard in Georgia that you're not, from some hipsters, that you're not supposed to wear socks, and they all wore socks. But this is really your chance to ask some tough questions. So we're gonna save a lot of time for questions from the audience. Okay, Chris, your business model at Anduril. Let's talk about that. It's different than most defense contractors. You're identifying a need sometimes before the defense, capability with private funding, the development to deliver it, right? So for example, when you have a hardware solution that's needed, it might be beyond your core software platform. That's a great deal of risk and capital required. What is the experience you've had to absorb the risk and expense of hardware development, for example, without turning to the government?
Yeah. And it's worth kind of taking a second to say, well, why do we do this, right? There are plenty of companies that are essentially waiting for the government to tell them what to do and then give them the money to go do it. Our belief is really that in order to bring solutions that are going to be disruptive, surprising, alternative approaches to the problem, having the sort of agency and the ability to kind of get going with that is important. And ultimately as well, it has to do with the culture of the company. Engineers want to be able to solve a problem on the speed that the technology will allow them to work on, rather than the speed that the government or someone imposes upon them. At times for reasonable reasons, but nonetheless, it sort of slows down progress. It can become frustrating, especially if you're forced to kind of bill your time in 6-minute increments like a corporate lawyer. For us, the real focus, on the hardware side, and really for any kind of large investment that we are going to take on in the form of kind of independent R&D funding, really comes down to sort of the basic question of, are we solving a problem that anyone cares about and is planning to buy? And I think that's the theme that I would sort of keep coming back to here with respect to how do we get commercial technologies to transition? How do we get programs to scale and succeed? It ultimately comes back to this question of, if I solve this problem, with a prototype, with an initial MVP, is it actually something that meets a mission need, can deliver a mission outcome? It is something that someone is planning to take to scale. So it starts to look more like the way the commercial industry makes these decisions, which I have more of an incentive to put money up front if I have a belief that over a reasonable time period I can really be successful. So there are programs and examples where we've done this on the hardware side. Many of the early projects that we began in terms of counter-intrusion, counter-drone started that way. As we've grown and become larger, I think it becomes, in many ways, I think almost more important to see kind of more of a cost sharing. So for example, earlier this year, we acquired a company, with a lot of involvement and support from DARPA, Dive Technologies, making large diameter autonomous underwater vehicles. About 5 months later, we were on contract with the Royal Australian Navy to build out 3 extra large autonomous underwater vehicles. We are putting 50% of the development cost up ourselves. The Australian Navy, the Australian government is putting the other half in. At the end of the day, in sort of the expanse of the Department of Defense, this is not an enormous amount of money. It's a lot of money. But I think the more important thing about the contribution from the government in that instance is that it shows that they care, right? That they are a stakeholder, they have skin in the game, and there's an understanding that we're both in this together, and if we're successful together in this kind of relatively short, sort of rapid prototyping phase, there is a sort of program on the back end of this, an opportunity to really deploy in large quantities where they will get, a large-scale disruptive mission outcome. We will have the opportunity to make money and become a larger company and hire more people and commit more IRAD to develop more technology. So I think at the end of the day, this is capitalism, this is good, and that's kind of the sort of the thought process that we go through.
Thank you very much. Okay, Rusty, you've had the opportunity to work at DARPA on the Blackjack program, trying to incorporate commercial technologies into affordable, secure, and resilient satellite constellation for military use. Now you're working at a private company, and you're trying to move their private tech into government utilization. What experiences can you share on the challenges that you're encountering, and what could the government do differently to more easily adopt private tech?
Great. Yeah. Well, fortunately, I think we're really seeing a lot of walls falling in those areas for how the commercial tech can be used by the government. We're absolutely seeing that across the board. There's pushes being made. We heard about this morning by the keynote speakers to go fix some things that they're working on strategically to get that even to a higher gear. But in terms of our technology at Amazon's Kuiper, we have a proliferated LEO system. We have commercial technology, commercial approaches to how we're developing that, and we do the risk management. And then we're getting to an end state where we're developing this as a service. It's not a bespoke system that a government would own, right? It's a service. So you look at that arc of moving from big, large targets in space, the few things, to a proliferated architecture. You look at how you can move yourself to using the commercial technology and the commercial development cycles of 2 or 3 year cycles instead of 10 or 15-year cycles, so you're bringing the latest technology to the military and government users. And then you figure out how do you get that to a service. So I think when I look at that, I think the government's moving, has put Space Development Agency into play to look specifically at the proliferated LEO architecture. The Blackjack, DARPA invested large amounts, and Air Force, Space Forces came along for that as big supporters of the Blackjack program. So we're seeing how do you actually, and there's other folks in other parts of government that are actually experimenting with that area too. So we're seeing that shift really move in a good direction, I think, to proliferated, and how we can move in terms of chains to webs of things, of how we move the data. And then the second part, how to use commercial, you're seeing more and more of that. I do believe that most of what Amazon might be able to bring to the government, we can do without doing a cost plus EVMS system, right? Which is not commercial at all. Right. And I see there's the OTAs and the ability to do fixed price, and there's a lot of potential there. So that ball needs to continue to move forward. And then the third part is how do you get to as a service? And that one is a little tougher because right now the thinking is still bespoke systems, and there are certainly plenty of things, especially in the military, where you have to have the military own and operate the actual piece, right? So how do you augment, how do you support in a way that actually provides value to the government user in a way that lets you in to learn about it, demonstrate that capability, and then turn on the service in a continuous arc without what Undersecretary Hsu said this morning about that 2-year process of end the demo, then wait for 2 years to get it programmed and off you go. And if we're doing our investment, and Amazon is investing $10 billion of its own funds in the Kuiper system, how do we actually get that so that we can support the enterprise and government users in a way that's useful, get into the study phase where there might be early billets so that security folks we can look at the secure side of things. How do you get to a demonstration phase, prove that you have TRL 789 capability that is valid and relevant to what the government user needs, and then how do you get to immediately move to a service? It can be small, that ramps up over time, but without that gap, because when you're doing your own funding, having a big gap of between when you do the investment and there's any revenue is pretty deadly to the business case. So I think the major piece, what the government could do differently to ease private technology, is to find a way to have a continuous flow from that study with security and billets, because that's important for a lot of things that are going on there, to demonstration, to service capability that is a continuous arc instead of having the discretes in there. I know that people are working on it right now, but I think there's this awesome pivot to all the technology that's out there, and whether it's big companies like Amazon or a wealth of small companies that can bring up that new ecosystem, they would all benefit from having a very clear path to move forward along that arc. Assuming they're successful, they'll continue to move up and up in that augment as a service model that we think is so powerful.
Wonderful, thank you.
Thanks.
Okay. Victor, adaptive computing is the wave of the future, allowing hardware to be adaptive to each application's need, and you're at the forefront. So kind of share with me the examples of how you've been able to bridge the gap to win over sometimes an entrenched or late adopting customer. We talked about flexibility, agility, so want to hear your thoughts on that.
Yeah, I would say that when we first introduced, adaptive SoCs, and this is when we introduced multi-core ARM SoCs, like not just, the CPUs, but everything, having, local memory, multiple levels of caches, peripheral buses, and interfaces together with the FPGA, together with programmable I/O. It was a really new concept, and we did have to drive adoption and help people understand what they could do with this architecture. I mean, our traditional customers, this is back in around 2011 when we first introduced, again, at 28 nanometers, the first generation of having the Zynq product. Our traditional customers were familiar with the FPGA. They didn't really know how to use the multi-core SoC. And then some of the newer customers that were approaching this kind of architecture was familiar with the SoC and not as familiar what to do with, the flexible hardware. And then a lot of people started out with design teams where it was kind of a hardware software team, and they kind of over the wall, and that's really suboptimal, right? So we spent a lot of time upgrading the tools, both from a capability from the hardware side, but also up-leveling the level of design abstraction. So back in that time, we introduced high-level synthesis, more IP-driven design, and we just made the capability more powerful, and we had to show them reference designs and other things. I think since that first generation, you know, once the customers went through one cycle of learning, the next cycle was much more rapid, right? And they really were realizing the power of having software and hardware programmability together, as well as the fast feature velocity, right? And, you know, again, in the commercial sector, feature velocity is a very big deal. But in, you know, in military applications, you could have new waveforms deployed, you could change security protocols, you could, you know, I mean, with firmware upgrades, and now, you know, Tesla did this over the air, but you could do over the air, right, hardware changes with this kind of technology. You know, so now we're on, again, our third generation. With Versal, we've integrated AI engine, which is an architecture for driving AI. We have an integrated hardened knock and all kinds of other capabilities. So, you know, it continues. What I would say is that the uptake on adaptive SoCs, the design wins, have outpaced pure FPGA design wins now some time ago. And maybe the broader picture, now that we're part of AMD, and I'm really excited about, is that, you know, I mean, this is really a great time to be in computer science. Because, you know, you have domain-specific architectures coming out. You have distributed composable systems. Is about systems of systems. I mean, you get computing everywhere where data is at rest, where data is being generated, when data is in flight, you know. And really, adaptability is one very important aspect that not everybody understands. But it's really looking at how computing is happening everywhere all the time. And it's just a great time to innovate, right? So.
Awesome. Thank you, Victor. Okay, we're now going to hear, hopefully the audience has been tough on you guys. All right, so question from our audience. How do you see DoD adapting to faster procurement to insert commercial capabilities to the warfighter? Who wants to take this one first?
Is the assumption of the question that it's happening? So I think that there's a lot of desire to do that. I think there's you know, a lot of sort of genuine, sort of well-meaning intent to make that happen. I think the challenge becomes, how do you even sort of understand the problem that you're trying to solve to be able to evaluate what commercial technologies can be pulled in to do what? Which is kind of why I go back to the story I told at the beginning, right? Where from the industry side, and particularly kind of the non-traditional, you know, kind of commercial-based industry side, I'm much more interested in what DoD believes its problems are, as opposed to what they are, you know, at times very confident their solutions need to be. And, you know, I think that's where I'd love to see a lot more effort put into how do you define sort of, you know, in some ways, you know, kind of taking a page from DARPA's playbook, you know, kind of grand challenges or challenge problems where we're going to pick a problem that is operationally relevant, that is urgent, that people need solutions for. And we're actually going to create a mechanism or incentives for real disruptive solutions to be able to compete on a level playing field with everything else that's out there. And not just from, you know, sort of commercial industry, but anybody, right? I mean, traditional industry, FFRDCs, you know, whomever. The point being is, you know, I think there are areas of technology. It's not going to be, you know, aircraft carriers and long-range bombers, but there are plenty of areas of defense technology where we can be actually, you know, thinking about how we create more of a marketplace where you're competing more regularly, right? It's not like you win a program and then like tenure at a university, it's yours for forever. It's actually, how do you then sort of recompete that whole thing again so that the people who won know that their feet are still in the fire and they've got to bring their A game the next time. And the folks who didn't win, you know, have a real incentive to put their own investment in, you know, to really kind of up-level their technology. They have a sense of what, you know, kind of the market leader looks like. You know, in 18 months or 2 years or 3 years, they have another opportunity to take a shot at the title. This is something, again, I think in a lot of areas of defense capability, and in many sense, you know, the things that we kind of need most, right, in terms of like autonomous systems of all kinds, weapons and munitions and other things, we could just be doing this a lot more regularly and creating much more of an incentive and a pull for new and disruptive and surprising solutions to, you know, be able to compete on a level playing field.
Awesome. So, Rusty and Victor, you know, different industries, different perspective, then are kind of comment on that?
Absolutely. I mean, I see the DoD adapting to faster procurement in a few areas. Most places where I engage with military leaders will talk about they have a commercial shop to bring technology into what they're doing. It's a wide range of how quickly they're all doing that and how quickly they're adopting the technology. I think there's that model of you're going to have the DoD system that does its existing procurement and has its non-commercial capabilities that can be augmented with commercial. And then it becomes a discussion of how do you convert that so that the augmentation can grow over time. And then maybe the government bespoke elements or the other government elements can become backup to the commercial primary, right? That part hasn't adapted yet. So how do you augment? I'm starting to see that fire up with various levels across the DoD. And I think the next step is then lay out a path for the commercial to be successful, expand their capabilities. Don't give up the government element that's not commercial, because there's always going to need to be hardened other capabilities that commercial systems won't necessarily bring. But how do you set that balance, and how do you work with whatever service you're at or whatever group you're at in the government so that they can actually turn the dial over time as they see success on the commercial side? Thanks.
Yeah, I mean, first of all, I see a lot of convergence because, we've, at Xilinx, supported the defense industries for a long time, but I look at it, SWaP-C is really important. I heard earlier this discussion about, 5G. Well, you know what? They care about weight, size, weight, power, cost. And I see, security is increasing in criticality, not just, in data centers and places where you'd expect, but, cars. I mean, cars are intelligent digital platform, and, attack surface is huge. So I think one thing is that the time is more ripe than ever, because some of the requirements in the private sector are matching exactly sort of what you need. And then the last thing is I just think that, I think things even up the supply chain, not just procurement, but like encouraging development, advanced technology, and speeding that, delivery all the way through deployment is super critical, because you spend all this resources getting asymmetric capability, but then you dissipate a lot of it by waiting so long. And so I think it's just really critical that we find a way to get from initial innovation all the way out to deployment in the field.
Okay, great. Second question from our audience. Commercial technologies are sought because they are less expensive or more timely than those developed directly for military applications. But commercial systems are often intended to operate in benign environments. How should DoD balance the commercial benefits versus the mission assurance they need?
I'll take a stab. I guess I wouldn't, first of all, assume that DoD has a monopoly on mission assurance, right? I mean, I think security is pretty important to the financial sector and a lot of other parts of our economy. So in terms of like what we actually mean when we sort of talk about the bar for security, it's like pretty high in the commercial sector, right? I think the point is more around there are just assumptions about how the DoD and the people who make up the DoD have to be able to operate, where they're going to operate, the ways that they're communicating, the level of security, obviously, in different locations. I think that's where it's, to me, less about, kind of can you bring just pure commercial technology in, but more, can you actually start to think about areas of technology where either commercial can be adapted very quickly, or possibly even where you can have commercial practices and a sort of commercial approach to technology development that nonetheless is happening in sort of a defense unique way, right? So if you just kind of like rip an example out of the news, the Ukrainians are expending munitions faster than the United States can resupply them. Munitions are a pretty, kind of defense unique capability, but they're not like, an aircraft carrier. We could be building these a lot faster. More companies could be competing. We could have a much more robust and diversified industrial base if we were actually buying these things more often. And I think there too, it's more around, can I create kind of a commercial approach with commercial incentives for something that is nonetheless kind of a military unique system. And I think there's an enormous world of sort of, interesting creative space where the DoD could be thinking differently about that. And in some cases, it's going to be, a commercial solution that is nonetheless kind of modified for some of the unique requirements that DoD has. It's just the challenge of constantly managing that, or kind of requirements creep. So that something that is available and ready today does not take 10 years to become something that it arguably doesn't need to be.
Yeah, maybe the only real quick thing I would like to add is, once again, is like certain other applications in the embedded world. I think you should think about embedded as opposed to just pure commercial, because if you think about consumer, you'd say, yeah, that's like not nearly reliable enough. But I mean, automotive suppliers require very single-digit DPPMs, because if there's an accident and a safety thing, people die, and they have recalls, and that's a big deal, right? But also, I would also say that, once again, system-level engineering, where you architect in some tolerance for capability. Rusty and I were talking about some things that he had done in his background, and it's how you architect certain things in. So if you know the limits around these things at the system level, you address those, so you can take advantage of the rapid innovations out there.
Okay. All right. Next, or Rusty, do you have a comment, or you?
Well, I mean, I think the ability there for the commercial to it goes to my point I said earlier about how the government user, the government senior officials can look at the systems that are out there and say, all right, if we don't try to change the commercial to be as hardened as all the requirements creep that's out there, how do we actually use the system it is? How do we come to them a little bit and find that balance between what we need to do? Right now, our system is built to this spec that's for everything to be in a non-benign environment. But 50, 40, 20, 70% of my mission could be done with a system that meets commercial network requirements. And AWS at Amazon does have a high bar for how we do networks and how we actually do everything we need for our cyber protection. So there are many elements that you can bring if the government looked at it a little differently and said, this part could be commercial, this part needs to have a higher elements that might be non-commercial pieces, and then kind of let the commercial innovation cycles be evaluated with a recurring analysis cycle on the government side to say how could it be plugged in initially as an augment, and as the commercial folks get good at whatever that mission is, expand it from there.
Yeah, thank you. Okay, we must have an economist in the house. The next question from the audience: how do companies ensure U.S. technological advantage in the future while maintaining neutrality in the global marketplace?
Maybe I can take a crack at it, but I would modify it a little bit. I don't know that it's neutrality, just to emphasize the point I made earlier, is it needs to be market sustainable. Because if it's not market sustainable, even with the resources and the funds the government might be willing to put into it, it's just not going to work. And that also means that you want to be very careful about how much you regulate it so that you don't choke off the lifeblood of commercial enterprises, right? Now, certainly you still have to look at certain national security issues for sure, right? But I think it's trying to do that very thoughtfully, and I think part of that means partnering with the private sector to understand, what's the objective from a security perspective, how do we do that without causing lots of damage from a commercial perspective? Because in the end, part of the way the U.S. has the lead in semiconductors is the fact that we're very successful commercially, right? So it really goes hand in hand. And I think it's just part of it is, talk to the private sector. We want to partner, and I think we understand the markets. It's a very fast-moving market. It's very challenging for the government to understand the nuances, and but we would be happy to make sure that we achieve the security objectives that we need to achieve for the country.
Okay, thank you. Okay, rapid-fire question. We heard the risers today. They had posters, right? And they talked about their ideas that they're thinking. So let's say you were each 25 again, and you were those risers. What would be the technical discipline, and what would be maybe your idea that you'd be trying to talk about if you're a riser? You could do it all over again. What would you do?
I'll start. I mean, I think there's so many things happening in the quantum area for what's happening, where there's communication. We heard about PNT as a baseline for the quantum sensors. If you're trying to, I had a great professor at Purdue who said, always stick with the most innovative technology area and the most innovative company in that technology area that you can find and have a great career. You will always have a wonderful career. And I think some of these companies that are coming along with quantum solutions that are going to change the game for how we do communications, PNT, and everything else. If I was going to switch around right now to be 25 again, I think I'd get in the middle of that.
Okay, great.
It's interesting. I said maybe earlier I was EE, and I'd probably do something still in the same area, but what I would do is broaden it, because I think having depth in one area but having multidisciplinary is very, very important. I think very interesting things had to happen at the boundary of disciplines, at the boundary of cultures, I mean, you name it. But I do really think it's almost like another golden age of computer science. Not just AI, but in so many different areas, communications, quantum computing. So I'd probably still do that, but I would broaden with economics and sociology and anthropology even. I don't know. I think it's really important to have that breadth and depth.
Okay, thanks.
Yeah, maybe a different stab at an answer. I mean, my science degree was in political science. Nobody wants me building anything, not in the past, not in the future. I guess what I would say is, if I could go back and do it all over again, it's not a cop-out, but I would do what I've done in the sense of, I would go back to serve in government. And I guess my advice or, counsel, such as it's worth to folks that are out there, risers that are out there, particularly people who have like real science backgrounds, is government needs help with that too, right? I mean, there are many decisions, man, that I wish I could go back and redo with the benefit of having somebody in the room who had a technical discipline and technical expertise that we lacked at the time. We were making at times very important, very costly, very consequential decisions, and like, boy, would it have been great to have particularly a young person with energy and real sort of technical acumen in an area to say, that's a totally screwed up decision you're about to make because it's not technologically feasible or it's bad for any number of other reasons. Government desperately needs that kind of help, not just in the DoD, not just across the executive branch, but also in the congressional branches. So, cast a wide net and sort of look at those opportunities as well.
Okay. Thank you so much.